Hello. So third class of module 1. Third class of module 1 of signals and systems. Okay. Signals and systems first module third class. In the first class we studied different types of signals and systems. Introduction. In the second class we concentrated on periodic and non-periodic signals. This third class is the continuation of second class. In the second class, we studied the periodic and non-periodic signals in the category of continuous time systems. In this class, we are concentrating periodic and non-periodic signals of discrete time. Okay. So how can we check whether the given discrete time signals are periodic or not? If periodic, we have to find out the time period. So the condition for periodicity in the case of discrete time signals is x of n plus capital N is equal to x of n. So periodic signal shows the same characteristics after a certain time period. That certain time period in the discrete time signal is represented as capital letter N. X of n plus capital N. വെറുതെ എന്ന് പറയുന്നത് സ്മോൾ ലെറ്റർ ആണ്. എക്സ് ഓഫ് എൻ പ്ലസ് ക്യാപിറ്റൽ എൻ ഇസ് ഈക്വൽ ടു എക്സ് ഓഫ് എൻ ഫോർ ഓൾ വാല്യൂസ് ഓഫ് എൻ. ഇഫ് എ സിഗ്നൽ സാറ്റിസ്ഫൈ ദിസ് ഇക്വേഷൻ ഡെഫിനറ്റ്ലി ഇറ്റ് വിൽ ബി എ പീരിയോഡിക് സിഗ്നൽ. അതർവൈസ് it is not periodic signal. It is a non-periodic signal. X of n plus capital N is equal to x of n. X of n വെറുതെ പറയുന്നത് സ്മോൾ ലെറ്റർ n ആണ്. X of n plus capital N is equal to x of n for all values of n. That means if a signal shows the same characteristics for a certain time interval, then that signal is known as periodic signal. It shows the same characteristics after a certain time interval. Then those signals are known as periodic signals. Here some discrete time signals are given. We have to check whether the given discrete time signals are periodic or not. So once again I am repeating, x of n plus n is equal to x of n plus capital N is equal to x of n for all values of n. If a signal satisfies this equation, definitely it will be a periodic signal. So first question, the given signal is cos 2 pi by 3n. Cos 2 pi by 3n. The given signal is cos 2 pi by 3n. How can we check whether the given discrete time signal is periodic? It is very simple. The procedure of determining whether the given signal is periodic or not in the case of discrete time signal is entirely different from that of the continuous time signal. In the continuous time signal, how can we check the periodicity? How can we check whether the given signal is periodic or not? That we discussed in the last class. So the method of determining whether the given signal is periodic or not is entirely different in the case of discrete time signal. If the coefficient of n is a multiple of pi, the coefficient of n, the first question is a cos 2 pi by 3n is the given discrete time signal. In this problem, the coefficient of n is equal to 2 pi by 3 is a multiple of pi. Therefore, the given signal is periodic. Otherwise, if the given, there is no pi term in this signal. If it is cos 2 by 3n, that means coefficient of n is not a multiple of pi. Therefore, we can say it is not a periodic signal. But in this problem, cos 2 pi by 3n, the coefficient of n is equal to omega. The coefficient of n is equal to omega, digital omega, not equal to analog. Ohm in the symbol alla, w പോലത്തെ symbol ആണ് omega എന്ന് പറയുന്നത്, w പോലത്തെ symbol ആണ്. Continuous time system omega എന്ന് പറഞ്ഞാൽ omega is represented as letter ohm പോലെയാണ്. Okay, so coefficient of n is equal to omega is equal to 2 pi by 3. That means it is a multiple of pi. Therefore, the given signal is periodic. If it is periodic, we have to find out. The fundamental time period, capital N. So that is also entirely different than that of the continuous time system. How can we find out the continuous time period? Coefficient of n is equal to omega. Is equal to right side. Right? On the right hand side, you can check. On the right hand side of this slide, coefficient of n is equal to omega. It is not w, it is omega. Digital omega is represented like w. Is equal to 2 pi by 3 because cos 2 pi by 3n, the coefficient of n is equal to 2 pi by 3, which is equal to digital omega. Okay, discrete time signal omega, coefficient of n is equal to omega is equal to 2 pi by 3 is a multiple of pi. So the given signal is periodic. Then how can we find out the time period? Coefficient of n is equal to omega is equal to 2 pi by capital N. Another equation, coefficient of n is equal to omega is equal to 2 pi by n. That means 2 pi by n is equal to omega. The value of omega is 2 pi by 3. 2 pi by n is equal to 2 pi by 3. Please understand, omega is equal to 2 pi by n, general formula. Substitute the value of omega. What is the value of omega in this problem? 2 pi by 3. So 2 pi by 3 is equal to 2 pi by n. 2 pi by 3 is equal to 2 pi by n. So n is equal to 2 pi by n is equal to 2 pi by 3. So n is equal to 2 pi by 2 pi by 3. 2 pi divided by n is equal to 2 pi by omega. What is the value of omega? 2 pi by 3. N is equal to 2 pi by omega into m, where m is the smallest positive value of integer, which makes capital N will be a positive integer. So the fundamental time period n is equal to 2 pi by omega into m is equal to 2 pi divided by, what is the value of omega? 2 pi by 3. So 2 pi divided by 2 pi by 3 into m. That means n is equal to 3 into 2 pi into m divided by 2 pi. 2 pi cancelled. So n is equal to 3 into m. What would be the value of m which makes n will be a positive integer? Substitute m is equal to 1. The smallest m should be the smallest positive integer value. M should be the smallest positive integer value which should make n will be a positive integer. So substitute the value of m is equal to 1. 3 into 1 is equal to 3. If m is equal to 2, n will be an integer, but the value of m is not small. So m should be a smallest positive. m ന് ചെറിയ വാല്യൂ കൊടുക്കണം, പോസിറ്റീവ്. m ന് 1 കൊടുത്താലും 2 കൊടുത്താലും 3 കൊടുത്താലും n പോസിറ്റീവ് ഇൻറ്റിജർ ആകും. പക്ഷേ m ന് സ്മോളസ്റ്റ് പോസിറ്റീവ് വാല്യൂ ആണ് കൊടുക്കേണ്ടത്. സോ m should be the smallest positive integer value which makes n will be a positive integer. So substitute m is equal to 1. So n is equal to 3 second. I think it is clear. Once again, coefficient of n is equal to omega is equal to 2 pi by 3. It is a multiple of pi, therefore the given signal is periodic. Then how can we find out the time period? Coefficient of n is equal to omega is equal to 2 pi by n into m. General formula, you have to by heart it. Coefficient of n is equal to omega is equal to 2 pi by n into m, where m is the smallest positive value of integer which makes the capital value of n will be negative. So from that we can write n is equal to 2 pi by omega into m is equal to 2 pi divided by, substitute the value of omega, 2 pi by 3 into m. That means 2 pi divided by 2 pi by 3 into m means n is equal to 3 into 2 pi m divided by 2 pi. 2 pi cancelled. So n is equal to 3 into m. So m should be the smallest positive value which makes the capital N will be the smallest positive integer. So we have to substitute m is equal to 1. So 3 into 1 is equal to 3. So n is equal to 3. Clear? I think it is clear. m ന് ചെറിയ positive integer, smallest positive integer കൊടുക്കണം. That should make the capital value of n will be a positive integer. Okay, so the given signal is periodic. We find out the time period, capital N is equal to 3 seconds. Clear? Then one more problem which consists of two components. X of n is equal to cos pi by 3n plus cos 3 pi by 4n. Cos pi by 3n plus cos 3 pi by 4n. The given signal is equal to x1 of n plus x2 of n. x1 of n plus x2 of n. First of all, I am taking x1 of n. Up x1 of n is equal to cos pi by 3n. So this is a coefficient of n is a multiple of pi. Coefficient of n is a multiple of pi because coefficient of n is equal to omega 1 because x1 of n is there, x2 of n is there. So coefficient of n is equal to omega 1 is equal to pi by 3, which is equal to 2 pi by n into m and 2 pi by n1 into m1 or 2 pi by n1 into m. So coefficient of n is equal to omega 1 is equal to pi by 3, which is equal to 2 pi by n1 into m. Okay. So then we cross multiply. Pi into n1 is equal to pi into n1 is equal to 3 into 2 pi into m. So from this n1 is equal to 6 pi m divided by pi cancelled. n1 is equal to 6 into m. M should be the smallest positive integer which makes n1 will be the smallest positive integer. So if m is equal to 1, n1 will be the smallest positive integer. If m is equal to 1, then n1 is equal to 6 into 1 is equal to 6. So m should be the smallest positive integer which makes the capital N also the smallest positive integer. So we got n1. At this stage we can't say whether the given signal is periodic or not. So because x2 is there. In the same manner we can find out x2 is equal to cos 3 pi by 4n. The coefficient of n is a multiple of pi. So coefficient of n is equal to omega 2 is equal to 3 pi by 4 is equal to 2 pi by n2 into m. 2 pi by n2 into m. Okay, so from this we can find out n2. How? Just cross multiply. 3 pi into n2 is equal to 3 pi into 3 pi into n2 is equal to 2 pi into 4 into m. 3 pi into n2 is equal to 2 pi into 4 into m. From this you can easily find out n2. So thus we got n2 is equal to 8 into m. That means substitute the value of m is equal to 1, we will get n2 is equal to 8. So we got n1 is equal to 6m, n2 is equal to 8m. When substitute m is equal to 1, we get n1 is equal to 6, n2 is equal to 8. m നെ എപ്പോഴും ഒന്നാണ് കൊടുക്കാന്ന് വിചാരിക്കരുത്. m നെ ഏത് പോസിറ്റീവ് സ്മോൾ വാല്യൂ കൊടുത്താലാണ് n ഒരു സ്മോളസ്റ്റ് പോസിറ്റീവ് ഇൻറ്റിജർ ആവുക. അതിനനുസരിച്ച് വേണം. ഡോണ്ട് തിങ്ക് ദാറ്റ് ദ വാല്യൂ ഓഫ് m is always 1. Suppose n is equal to 8 by 3 into m. So you have to give the value of m is equal to 8 by 3 into 3. So 3 cancelled and will be a positive integer. Okay. ഇപ്പോൾ m നെ എപ്പോഴും പോസിറ്റീവ് 1 ആണ് കൊടുക്കാതെ ധരിക്കരുത്. If I'm repeating, if n is equal to 8 by 3 into m numerator 8m by 3. So m should not be 1. If m is equal to 1, 8 by 3 into 1 is equal to 8 by 3, which is not an integer. Therefore we have to substitute the value of m is equal to 3. Okay, just an example. So don't think that the value of m is always positive 1. The value of m should be the smallest positive integer value, which makes the value of capital N will be a positive integer. Okay, yes. So we got n2 is equal to 8 and n1 is equal to 6. So find out the ratio of n1 and n2. n1 and n2. The ratio of n1 and n2 is equal to n1 by n2 is equal to 6 by 8. When we simplify, it is equal to 3 by 4. So it is n1 by n2 is equal to 3 by 4. Okay. So n1 by n2 need not be an integer. So what is the condition for the periodic property of discrete time signals? Coefficient of n should be a multiple of pi. In x1 of n and x2 of n, coefficient of n will be the multiple of pi. Therefore the given discrete time signal is a periodic signal. So that is very clear. So in the case of continuous time signal, we need to check t1 by t2 should be an integer. In the case of discrete time signal, n1 by n2 should not be an integer. So we need to check in the beginning of the problem itself whether the coefficient of n is a multiple of pi. In both cases, in x1 of n and x2 of n, the coefficient of n is a multiple of pi. Therefore the given signal is periodic. To find out the periodic property, coefficient of n in the first term is equal to, in the earlier method we can find out n1, we can find out n2, then find out n1 by n2, then cross n is equal to n1 by n2 is equal to 3 by 4. Just cross multiply, then 4n1 is equal to 3n2. We know the values of n1 and n2. n1 is equal to 6 and n2 is equal to 8. 4 n1 is equal to 3 n2 is equal to 4 into 6 is equal to 3 into 8 is equal to 24 seconds. So the given signal is periodic. The reason is the coefficient of n is a multiple of pi. And finally we found out the period capital N, fundamental time period capital N is equal to 24 seconds. The fundamental time period capital N is equal to 24 seconds. I think it is clear. So in this manner we can decide whether the given discrete time signals are periodic or not.